Integrated design with multiple energy efficiency measures can reduce energy use at least half of the conventional building, and gains greater than 80% have been achieved. The emerging trends of intelligent buildings and green buildings entail the use of modern technology, smart materials, and eco-friendly design. For example, I have seen the hollow building material made out of fly ash. Not only is more environment friendly, but also better insulator of heat and cold. Such eco-friendly, cost-effective material can make the building more energy efficient. The another one, alternate source of energy. Let me discuss about the profile of a renewable energy system. Firstly, I would like to talk to you on the solar energy. Solar energy in particular requires unique massive application in the agriculture sector, where farmers need electricity exclusively in daytime, like in India. This could be the primary demand driver for solar energy. Our farmers' demand for electric power today is significantly high to make solar energy economically large scale. Shortage of water, both for drinking and farming operation, can be met by large-scale seawater desalination and pumping inland using a solar energy supplemented by biofuel wherever necessary. Third area, terrestrial solar power. The current high capital cost of terrestrial solar power station can be reduced by grid-locked 100 megawatt site, very large solar photovoltaic or solar thermal power stations. In the very near future, breakthroughs in nanotechnologies promise significant increase in solar cell efficiency from currently what you are getting 15% value to over 50% levels. These would in turn reduce the cost of solar energy production. Science laboratories should mount an R&D program for developing high efficiency CAD carbon nanotube based photovoltaic cell, and also advance in the solar thermal technology. The potential of terrestrial solar energy on the global arena is impressive. It is documented that concentrating solar power plant built on less than 0.3% of the desert in North Africa and Middle East to generate sufficient energy to meet the local electricity needs of the region and that of the entire European region. India is also pursuing large-scale mission for the implementation of solar energy in various states. Recently, Gujarat, the western state in India, installed a mega power plant of 200 megawatt of solar power. And this state has installed capacity of solar power of more than 600 megawatt, which is fed into the grid. The Economics reported in April 2012 that India's share of new global solar installation will rise from 1% 2012 to over 5% 2015. Indian government has already set into vision of 20,000 megawatt power of solar power by 2022. Now, nuclear power generation. Next area is nuclear power generation. Nuclear power generation has been given a thrust by the use of uranium-based fuel. However, there will be a many-fold requirement due to increase in nuclear power generation, even to attain a reasonable degree of energy independence. We would need to develop technologies for wider spectrum of fissile materials found around the world. For example, India has 1/4 of the world's thorium reserves. Therefore, it is essential India will be pursuing the development of a nuclear power using thorium reserves, of which we are higher in many nations. Now, the next area, municipal waste as a source of power. Municipal waste as a source of power. In the power generation sector of the energy economy, we need fully use the technologies now available for generating power for municipal waste. Today, there is hardly any significant energy being generated from the waste. In India, studies indicate that as much as 5,800 megawatt power can be generated by setting up 900 electric power plants spread over different parts of the country, which can be fueled by municipal waste. The electric power generation and creation of a clean environment are the twin advantages. I am sure this model is replicable by all the nations of the world. Now, how do you replace the petroleum which you are using every day? Now, let me now talk about the use of biofuels. One such biofuels crop is that of a jatropha, which is widely popular in India. Once grown, the crop has a life of 50 years. Moreover, the plant can grow in a wasteland and hence does not create a substitution of food crops. Each acre will produce about 2 tons of biodiesel at about half the dollar per liter. Biodiesel is a carbon neutral and many valuable byproducts flow from the agro industry. Intensive research is needed to burn the biofuel in internal combustion engines with high efficiency, and this needs to be an urgent R&D program throughout the world. India alone has a potential to produce nearly 60 billion tons of biofuel annually, thus making a significant and important contribution to the goal of energy independence. Indian Railways has already taken a significant step of running 2 passenger locomotives and 6 trains in diesel multiple units with 5% blend of biofuel sourced from its in-house electrification plants, esterification plants. What is needed is a full economic chain from farming, harvesting, and the extraction of esterification, blending, and marketing. Apart from the employment generation, biofuel has a significant potential to lead towards energy independence. Similarly, algae oil, one of the best and most efficient biofuel available in algae oil. Algae oil is far superior in terms of yield per hectare and compared to conventional biofuel crops like corn, which generate about 172 liters per hectare. Algae oil can generate more than 100 times that of yield. Moreover, it can be grown in marsh, in shallow regions of the sea, which are otherwise unutilized. The challenge is to develop better technologies which can bring down the cost of regeneration of algae oil. Now finally friends, the vision for energy independence will not be complete without stressing on the need for reducing the emission, thereby protecting the environment. With my team, I calculated that currently the emission per unit of energy used through various means comes out to be around 1.3 kilogram of CO2 per watt of power per year. 1.3 kilogram of CO2 watt of power per year. Through a multi-pronged effort, this should be brought down to under 0.65 kilogram of CO2 per watt in the next 20 years, which will also bring down the global emission of GHG. This will include development and implementation of biofuels and the alternative source of energy, and also improvement in the efficiency of energy usage. The challenge of reducing our dependence on fossil fuel and conserving the environment is a global challenge which would necessarily require a global platform for implementing solutions which are efficient and economic in all the nations across the world. Energy